Alright, so welcome back again. My name is Jesse, and in this wonderful tutorial, we're trying to see how to do linear programming with a very nice package in Julia called JuMP, right? So JuMP is a very nice library that allows you to be able to do different forms of optimization problems such as linear programming, mixed integer programming, and then the rest. So let's see how to work with this particular package. So first of all, in case you don't have it, you can just go back to your terminal, then you can install it. So I'll go back to my terminal. Now go to my Julia repo. I want to install it from the terminal. Then from here, I can just add the particular package that I want, right? So let's add JuMP. So I'll go back to my package mode using this particular command here, right there, bracket. Then I'll just go with add JuMP. That is how to add JuMP on your Julia workspace. Perfect. So let's see how to work with it. So in doing every format of optimization problem, specifically linear problem or programming, what you're supposed to do is you must first of all define or declare the solver that you want to use. There are several solvers, as you can see from here. We have several solvers that you can use in Julia. So most of these solvers have support for different types of problems that you want to solve. So you can see from here that we have different solvers. So these are the solvers, and then these are the particular support they have. So linear programming, mixed integer linear programming, and the rest, right? But we're using this particular solver here, so we're installing it for this particular session. Perfect. So that is the first thing. Then you declare your variables, then you define your constraint, right? Your limit, then you define the objective function, then you invoke your solver. So let's pick a particular problem and try and see how to use linear programming using JuMP to solve it. So this is the problem that you have. We are supposed to maximize fx plus 6y, which is subject to this particular constraint, and these are our variables. So a simple picture is this. A simple picture to help us understand that anytime you're giving something like this, so we have three key elements. So you need to know your variables. So these are going to be our variables x and y, right? In this case, this x and y, which is going to have an upper or a lower bound. It must not be less than 0, right? Perfect. Then we also have our constraint. So the constraint is going to be the limit. What are our constraints? What are our restrictions for our activity, for the task we want to do? So this is very simple. In case you are given a question like this, it is what is term subject to. So this is going to be our constraint. Then the next thing is our objective function. What is our goal? What do you want to achieve, right? So our goal is to maximize this particular function, fx plus 6y. So that is our objective function. So the three elements: your variable, you define your variables, or you create your variables, you specify your constraint. It's very simple. Then you specify the objective function, so it can either to maximize or minimize. So let's see how to work with it. So I'll just come back again to my Jupyter notebook, then you load JuMP, right? So by now it has finished installing. So let's add our solver. So add JLPK, right? I'm going to add our solver, then I'll come back again, and then we'll just load my package. So JuMP, to load our package. Perfect. And then from here we will try and see the various methods of this particular package. So it's going to be the methods, which is similar to DRL, this option in Python. So it's going to be my var info, and I'm passing my JuMP package, right? So JuMP is going to give me all the various methods and activities I can do. And from here you see that we have several macros, right? So the most important one we're using is the constraint macro to define our constraint. We have our variable macro to define our variable. So we have for single and then for multiple. Perfect. And also have our model, which is this, right? Perfect. So let's see how to work with it. So first of all, we need to create our model and then declare our solver, right? So let's specify. I'm going to load our solver. It's going to be my using JLPK. Then from here, I'm just going to, first of all, let's define our model. It's going to be M for model, right? It can be anyhow. Then I'm going to call it as my model, which is coming from JuMP, as we saw earlier on. So this model here is the model coming from JuMP here. This particular one, right? It's a function or a data type, right? Perfect. Then I need to specify the particular solver. What do I want to use to solve my question, right? So I'll pass in my JLPK.optimizer. So there are several ways you can do, so that is the simplest option, right? Perfect. So now we're going to create our model, then we're going to specify the solver we want to use. Perfect. Now let's first of all create our variables. So based on the question that we had, which was this particular question, so these are our variables x and then y, right? So we're going to specify our variables. We're going to create our variable. So to create a variable, very simple, just go with the macro variable. Then you specify the model. Then you specify your variable. So x must be greater or equal to 0, right? Then let's create another one. So variable for the model. This is m. Let's call it m, or you can just call it model anyhow you want it to be. So let's call it m or model to save us time. So model, and then we just come back again so that it makes it easier for future people to remember. Right? Perfect. Then this is going to be y. So these are our lower limit, right? It must not be more than this. Perfect. We have created our variables. Now let's specify our constraint. Specify constraint. Don't know how to spell constraint. And one thing is that anytime you are given a question like this question that we have here, something like this, it's very simple for you to know the constraint, right? So this is the constraint. Subject to is a constraint. So let's try and see how to do that. So this is the constraint, and then this is going to be our variable. So we have defined our variable. Let's work on our constraint. So I'll copy this one. I don't know whether the audio is misbehaving, but let me know in the comment section below. So to specify the constraint, just go with the macro constraint, right? Constraint. Then you just pass in your model as usual. Then you specify the constraint. So this is going to be our constraint for the first one. So let's make it like this, and then this. The macro constraint, our model, and you specify, right? So that is something very simple. And once you have to notice that when you are doing this, you should make sure that you multiply this, right? So that it works perfectly well. So this is going to be our constraint. Perfect. So we have gotten our model, our variables, our constraint. Now let's define our objective function. So it's very simple. Just go with add the macro objective, right? This is going to be our objective function. Then you specify your model. Then what do you want to do? So this one takes 3 arguments, the model. Then in our question that we had, we are supposed to maximize something. So that's going to be the next argument. We're supposed to maximize something. Then I'll paste in 5x plus 6y. Very simple. So we're supposed to maximize. Then what are we maximizing? 5x plus 6y. So in this case, you don't multiply. You just go straight away with this, right? You don't do this. It's going to understand it. So that is our objective function. You have defined them. Now to see everything that we have done so far, a simple summary. Very simple. Just go with my macro show. You can use display anyhow you want it to be. So show, then my model. So this will give us a summary of whatever we have done. So based on the summary that we have, our model, we are using a JuMP model, and we are supposed to maximize. It's a maximization problem as we specified here, and we have 2 variables x and y, and these are our solver, and then this is exactly the same thing that we saw in the question below. So if you're able to get something like this, that means that it's simple for you. You can solve it, right? Perfect. Now let's see how to solve it. So to solve it is very simple. Just go with solving or optimizing. Just go with my optimize bank. So this is a mutating function. Then I'll pass in my model. So this is going to optimize it and give us a result very fast. Perfect. So we have seen it. To be able to get our status, right? So we can just go with my termination status. So this one helps us to know whether our model that we are trying to optimize was able to arrive at an optimal solution or not optimal solution. So I'll just pass in my model. So this is going to tell me that we got 1. So the termination status code is 1. That means that we got an optimal solution. To be able to get all of the various status codes, just go with my display type of then moi dot optimize optimal, right? So this is going to display all the various status code for determination. So these are going to be the status code. So 1 means it's optimal, you are able to find an optimal solution. 2 means it's infeasible, right? That means that the problem is not feasible. You can't do it, right, in real life. Very simple. So these are all the codes. Now let's see how to get our actual value, right? We have seen that we have gotten an optimal solution. Now to be able to get the values, to get our result, just go with the show macro, right? Then just pass in value. I want to get my one for x, show value for y. So this one give us the right values that we need. So these are the values that we need. So we need 5 of x and then 2 of y to be able to give us our maximum result for that particular function. So let's check for the objective value. So to get the objective value, just go with this, the objective value. So you can just go with this, show objective value, and I'll pass in my model. So this is going to put in this particular value that we have into our optimization function and return our result. Very simple, right? So that is something very simple. So we have seen how to do simple linear programming using JuMP by defining our variables, constraints, and an objective function. Right, so that is something very simple. So if I put in these values f and x, right, x and y into my objective function, if I put it back into my objective function, I'm going to get the right result, right? So let's try an example. So we realize that our objective function was fs plus 6y, right? So if I put in these values, I must get this. So let's try it. It's going to be this. So print. This is Julia, so print line, right? Prepare to leave a line below it. Then let's put in our values. So it's going to be 5 by my value for the s variable plus 6 times the value for my y variable. And now it has given us the same thing that we had, right? Very simple and very nice. So the basic idea behind trying to solve any problem, especially linear problem, in Julia is to go with this particular approach. You declare your solver, you create your variables, you define the constraint, define the objective function, then you invoke, right? Very simple and very nice. So we are using JuMP. Then to be able to define our model, we just define our model with this option. Then you specify our solver. There are several solvers. Then you create your variables. Then you specify your constraint. Then from there, you can just move on to specify your objective function, what you want to achieve. Then you can show the summary of the entire stuff. Then you can invoke optimization, right, by calling optimize function on our model. Then you can get the result using show, right? Perfect. So that is how to do simple linear programming using JuMP. So thank you for watching this tutorial. In case you have any question or contribution, you can just put inside the comment section below. This is a very simple case, but there are complex cases that you can do with it. You can check the logs and check the links below for more. See you another time. Stay blessed. Bye.